The rock in a particular iron ore deposit contains 80% Fe2O3 by mass. How many kilograms of the rock must a mining company process to obtain 1.2 times 10 raised to 3 kilograms of iron? Okay, so we will be using dimensional analysis to solve this problem. So we start with the given. We are given 1.2 times 10 to the 3 kilograms of iron. So you write that 1.2 times 10 to the 3 kilograms of iron, or Fe. First thing you need to do is to convert this into grams. So from kilograms of Fe, we convert that to grams of Fe. And we know that for every 1 kilogram, there are 1,000 grams. So as you can see, the kilograms of Fe would cancel out. Now we have grams of Fe. Next is we convert grams of iron into moles of iron. So we will use the molar mass of iron. So again, from grams of Fe, we will convert that to moles of Fe. And 1 mole of Fe, the molar mass of Fe is 55.85 grams per mole. So 55.85 grams in 1 mole of Fe. So the grams of Fe would cancel out. Now you have moles of Fe. Next, what you're going to do is to convert moles of Fe to moles of Fe2O3. Okay, so how do you do this? You simply look at the chemical formula. Fe2O3 has 2 ions. So that means 1 mole of Fe2O3 has 2 moles of Fe. So moles of Fe will cancel out. Now you have moles of Fe2O3. Next, we will now convert moles of Fe2O3 into grams of Fe2O3. So we will now use the molar mass of Fe2O3. So if you compute the molar mass of Fe2O3, it's about 159.69 grams of Fe2O3 for every 1 mole of Fe2O3. So here, as you can see, the moles of Fe2O3 would cancel out. Now we have the grams of Fe2O3. But we're not yet done. In the problem, it says here that the rock contains 80% Fe2O3 by mass. So what does percent means? Percent means per 100. So that means when you say 80% Fe2O3 by mass, that means that for every 100 grams of the rock, it contains 80 grams of Fe2O3. Okay, so now we can multiply another conversion factor. Let's just continue it here. You can multiply this now Okay, you multiply this by... Okay, so for every 100 grams of the rock, it has 80 grams of Fe2O3. So the grams of Fe2O3 would cancel out. Now you have the grams of the rock. But the problem is asking for the kilograms of the rock. So you need to multiply this further by a final conversion factor from grams of rock to kilograms of the rock. So again, we know that 1 kilogram is equivalent to 1,000 grams. So the grams of rock would cancel out, and now we have reached our final unit, which is the kilograms of the rock. So now that we have the final unit, all you have to do now is to solve everything in your calculator. Okay, so let me guide you in this. So that's 1.2 times 10 to the 3. You multiply that by 1,000 divided by 1. You multiply that by 1 divided by 55.85. You multiply that by 1/2. You multiply that by 159.69 divided by 1. You multiply that by 100 over 80. And then you multiply that by 1 over 1,000. Okay, and from that, you will get approximately, see if you solve that, you will get approximately 2144 kilograms of the rock. Or if you want your answer to be in proper significant figures, you can express this in 2 significant figures. You can write your answer as 2.1 times 10 to the 3 kilograms of the rock. And this is the answer to the question.